If you could travel at the speed of light, 186,000 miles per second, it would still take you 93 billion years to cross the observable universe from one end to the other. And yet, what we can see might be just a tiny fraction of what actually exists. Today, we're taking a journey through cosmic scales, from the familiar to the incomprehensible. By the end, you'll never look at the night sky the same way again. Let's start with something we understand. Earth. Our home planet is about 8,000 miles across. You could drive around the equator in about 2 weeks if you never stopped. The moon, our closest celestial neighbor, sits about 240,000 miles away. That's roughly the distance of driving around Earth 10 times. Every human who has ever left Earth's orbit traveled this distance. 24 astronauts during the Apollo missions. But this is just the beginning. To understand the true scale of the universe, we need to think bigger, much bigger. The Sun sits at the center of our cosmic neighborhood, about 93 million miles from Earth. We call this distance one astronomical unit, or AU. At this scale, Earth is just a pale blue dot. Light from the Sun takes 8 minutes to reach us. That means when you feel the warmth of sunshine on your face, you're feeling light that left the Sun while you were brewing your morning coffee. But the solar system extends far beyond the 8 planets. Neptune, the outermost planet, orbits at 30 astronomical units, 30 times Earth's distance from the Sun. At the speed of light, it takes over 4 hours to get there. Beyond Neptune lies the Kuiper Belt, home to Pluto and countless icy bodies. And beyond that, the Oort cloud, a spherical shell of comets that extends nearly 2 light years from the Sun, marking the true edge of our solar system's gravitational influence. If the Sun were the size of a basketball, the Oort cloud would extend for over 30 miles in every direction. To leave our solar system and reach the nearest star, we need to think in entirely different terms. Our nearest stellar neighbor is Proxima Centauri, a small red dwarf star 4.24 light years away. That's about 25 trillion miles. If you could drive there at highway speeds, the trip would take over 50 million years. Voyager 1, humanity's most distant spacecraft, has been traveling for over 45 years and has only covered about 0.002% of the distance to Proxima Centauri. Within 30 light years of Earth, there are roughly 400 stars. Some are bright giants, others are dim dwarfs, barely visible even with telescopes. Each one is a sun in its own right, potentially hosting worlds we've never seen. But even this neighborhood is microscopic compared to our galaxy. The Milky Way is a barred spiral galaxy containing between 200 and 400 billion stars. It's about 100,000 light years across, so vast that light takes 100,000 years to travel from one side to the other. We're located about 27,000 light years from the galactic center in a minor spiral arm called the Orion Spur. We're essentially in the galactic suburbs. At the center of our galaxy lies Sagittarius A star, a supermassive black hole 4 million times the mass of our Sun. The stars near it orbit so fast they complete a full revolution in just 15 years. Yet they're still light months away from the black hole itself. The Milky Way isn't just wide, it's also relatively flat, like a cosmic pancake about 1,000 light years thick. But surrounding this disk is a spherical halo of ancient stars and mysterious dark matter extending perhaps 600,000 light years from the center. If you could shrink the Milky Way to the size of the United States, our entire solar system would be smaller than a single blood cell. And yet our galaxy is just one of countless others. The Andromeda Galaxy, our nearest large galactic neighbor, lies 2.5 million light years away. It's slightly larger than the Milky Way and contains roughly 1 trillion stars. Despite the vast distance, Andromeda is actually moving toward us at 250,000 miles per hour. In about 4 billion years, our galaxies will collide and merge. The Milky Way and Andromeda are the two dominant members of the local group, a collection of about 80 galaxies bound together by gravity, spanning about 10 million light years. But the local group is just a small gathering in a much larger structure. We're part of the Virgo supercluster, which contains at least 100 galaxy groups and clusters, stretching across 110 million light years. And even this is part of something larger, the Laniakea supercluster, a structure containing 100,000 galaxies across 520 million light-years. At this scale, the universe begins to look like a cosmic web, vast filaments of galaxies surrounding enormous voids of nearly empty space. These structures are shaped by dark matter, the invisible substance that makes up 85% of all matter in the universe. Now we reach the ultimate boundary, the observable universe. The observable universe is a sphere centered on Earth, extending 46.5 billion light-years in every direction. Wait, didn't we say the universe is only 13.8 billion years old? How can we see 46.5 billion light-years away? The answer is cosmic expansion. The universe isn't just filled with galaxies moving through space. Space itself is expanding. The most distant galaxies we can see have been carried away from us by this expansion, and they're now far more distant than their light travel time would suggest. The edge of the observable universe isn't a physical boundary, it's simply the limit of what we can see. Light from beyond this horizon hasn't had time to reach us yet. Within the observable universe, astronomers estimate there are about 2 trillion galaxies, each containing hundreds of billions of stars. The total number of stars might exceed 10 to the 24th power. That's more stars than grains of sand on all of Earth's beaches. Every time we point our most powerful telescopes at a seemingly empty patch of sky, we find thousands more galaxies stretching back to the early universe. From Earth to the Moon, to the Sun, to the edge of our solar system, from neighboring stars to the Milky Way's spiral arms, from Andromeda to the local group, to vast superclusters in the cosmic web, and finally to the observable universe itself, 93 billion light-years across. And yet, the observable universe might be just a tiny fraction of the total universe. Beyond what we can see, space may extend forever, or it might curve back on itself in ways we can't yet comprehend. We are, quite literally, living on a speck of dust, orbiting an average star, in a typical galaxy, in a universe so vast that human minds can barely begin to comprehend it. But here's the beautiful part. From that tiny speck, we figured all of this out. We mapped the cosmos, measured its age, and understood its structure. Not bad for a species that's only been looking up for a few thousand years. The universe whispers its secrets to those who listen. And the more we learn, the more we realize how much more there is to discover. If you enjoyed this one, don't forget to hit like and subscribe to keep in touch with subsequent updates.